Hello everyone. Today we will look into graphing quadratics with the b values. And earlier we've learned about graphing quadratics with a and c, and then we learned about the roles of a. Let's review that quickly as well. A role of a would tell us if there's a vertical stretch or compression. We will look at the a value. If a value is, absolute value of a value is greater than 1, then it's a stretch. If absolute value of a is less than 1, like a fraction, then it's a vertical compression. A value also tells us whether the graph should open up or open down. If a value is positive, graph opens up. A value is negative, graph opens down. Today we will focus more on calculating the b value and using the b value in our graphs. B value tells us that there is a horizontal shift when compared to parent function. Our parent functions had the vertex at 0, 0. If you see a bx value in a question, it means that your vertex has been shifted to a new location. So our parabola is going to start from that point. C value tells us that we have a y-intercept, and then we can use that to find the y-intercept. Now, in order to graph the parabola when there is a b value, we are going to first identify the location of the vertex. In order to find the location of the vertex, we are going to use the vertex formula, x is equal to negative b over 2a. We are going to substitute that in our equation, those values from our equation. So our a value is 2, b value is negative 8, c value is 6. Let's substitute all of them into x is equal to negative b over 2a, negative of negative 8 over 2 times a, negative of negative 8 over 4, which is equal to 2. After finding the x coordinate, now we are going to find the y coordinate. To find the corresponding y coordinate for any given x value, we will just substitute that x value into the original equation. So we are going to do that to find the y value. 2 times x squared minus 8 times x plus 6. This will be equal to negative 2. After finding these values, now we know the coordinates of the vertex, x2, y negative 2. We are going to graph our vertex point first. x2, y negative 2 will be located right here on our graph. And now we are at the step of drawing the axis of symmetry. Axis of symmetry is going to be a vertical line passing through the vertex. So I will draw a vertical line passing through our new vertex point. And axis of symmetry will be an equation, x is equal to something. In this case, x values are at and positive 2. So x is equal to 2 is the equation of our vertex. By just looking at the equation, we can determine whether the graph should open up because the a value is positive, or graph should open down because a value is negative. Please make this change to a less than symbol to indicate that a value is negative. Find additional points by creating xy table. At this point, we are going to use 0, 1, 2, 3 easy numbers to evaluate the corresponding y values for these x values. After that, we will just connect the dots, connect the points to graph our parabola. Let's put the values of each x value in here into the equation to find the corresponding y values. 2 times x squared minus 8 times x plus 6 equals 6. 2 times 1 squared minus 8 times 1 plus 6 equals 0. And then we will do the next one, equals negative 2. And continue with the next one, 3. It will be equal to 0. Let's graph these points on our coordinate plane. And my points are, in this case, x0, y6. When x is 0, y value will be 6. That's 1. When x is 1, y is 0. Right here. When x is 2, y is negative 2. We already have that. When x is 3, y is 0. Right here. As you can see, we already have an essence of the parabola. We can actually go ahead and graph the parabola passing through these points. As I know that the parabola is symmetrical by the axis of symmetry, So if I have one point on one side of the line, I can make the same point on the other side as well. So I can put another point right here, so I will have matching points. Now, in our examples, if you would like to find better points for your parabola, you can start finding x values around the vertex. Since our vertex was 2, it could be easier to look at the values, maybe 0, 1, 2 less than 2, and then 3 and 4, 2 units more than 2. So we will be exploring the values, y values around the vertex. We already know where the vertex is at 2, so we don't have to look at that one, and we would go 2 units below the vertex to find the x values, 2 units above the vertex to find the x values, and find the corresponding x values that way, which will give us 4 solid points to graph our parabola. Including the vertex, we would have 5 points, and which would be enough points to graph an accurate parabola. We are now looking at checking the y-intercept. In this case, our y-intercept is actually positive 6. In our problem, y-intercept was 6. It also confirms. We connect all the points with a smooth parabola. And there is a calculator step that we can use for our table as well. We can type the graph into y is equal to screen, then select second table for all x, y values. Observe that y values are changing pattern at the vertex. Let's do these steps with a calculator as well. Please grab a calculator and follow with the steps. On our calculators, we are going to type the equation in the graph section. So go ahead and push the y is equal to button on the top left, and then you should see the graph equation section. And go ahead and type the equation in your graphing section. After typing the equation, we are going to hit second table. Table is the graph button. Second table. It will give us x and y values for our quadratic equation. Among these, we can choose the ones that are going to work with our equation, and then use these points to accurately graph our point. As you can see, when we had 0, y value was 6. When x is 1, y is 0. When x is 2, y is negative 2. When x is 3, y is 0, 4 is 6, and so forth. As you can see, at the vertex, y values are changing. Y values has been decreasing until the vertex. It goes as low as negative 2, and then they start increasing after the vertex. In order to see negative values, you can move with your arrows, upward arrow, to see more negative values if you wish. And then now you can clearly see that y values are decreasing until negative 2, and then increasing back up, and just like our parabola. The horizontal translation is shifting the vertex, shifting the parabola by its vertex. X value on the vertex will tell us the amount of horizontal translation. Shifting the parabola by its vertex is called the horizontal translation. The x value of the vertex gives us the horizontal shift. Let's look at our second example. On this second example, we are first going to find the vertex again. And in our vertex value, we are going to substitute x is equal to negative b over 2a. And here's our a value, b value, and c value from the original equation. Let's substitute that in here. X value will be equal to negative of negative 2 over 2 times a. We're going to have to do order of operations in here. And I have negative of negative 2 divided by 2 times 1/2 is 1. And this whole result is going to be equal to 2. After finding the x vertex, we are now going to find the y vertex, y coordinate of the vertex. We will take this value 2, and then we will substitute into the equation to find the y value. So our y value will be equal to 1/2 times 2 squared, which will be x squared, minus 2 times x, which is 2, minus 3. Let's evaluate that. 1/2 times 4 is 2, minus 4 minus 3. Our result is going to be -5. After we find both of those coordinates, now we are done finding the vertex. Our vertex coordinate, let's write that in here. X is 2, y is -5. We can now graph the vertex on the coordinate plane. When x is 2, y is -5, vertex is located right here. And after finding the vertex, we can now create the axis of symmetry. Axis of symmetry is a vertical line passing through the vertex. Draw a vertical line passing through the vertex. This is going to be our axis of symmetry. And since it's a vertical line, equation of the vertical line is going to be x is equal to 2 line. After finding that, now we're going to go on to the third step here. Please change this to a is less than 1 again. So when a is less than 1, graph opens down. It looks like a is positive, so we know that our graph is going to open up. We're going to find additional points by creating an xy table. We are going to give some x values, and whenever we are choosing the x values, we are going to choose the x values that are going to end up giving us an integer coordinates as opposed to decimal coordinates. That's why it kind of makes sense to put coordinates that are multiples of 2. Choose coordinates that are multiples of 2s. In order to find the values on these, let's use our calculators again, or you can calculate each of them manually as well. On your calculators, go ahead and type the equation on y is equal to section. After you type your equation on y is equal to section, you will push second graph. Graph is on the top right, and that will give us the table. On this table, we can see our values already. When x is 0, and y value is -3. When x is 2, y is -5. So here's -3, -5. I'll pull up my calculator again to see the other ones as well. When x is 4, y is -3. When x is 6, y is +3. -3, +3. When x is 8, it doesn't show up on my graph, so I'm going to scroll down a little bit to see that value on my table. 8 will be 13, and that's the last value I'm going to use in here. And we can again find these values manually as well. Let's graph each of them on the coordinate plane. 0, -3 will be located right here. Let's use different color. And next to -5, whenever x is 2, y should be -5. It's where exactly we have the vertex at. 4, -3. When x is 4, y is -3. And when x is 6, y is +3. 6, +3 located right here. And 8, 13 may not fit on our graph, so we will count to 8. And then 13 will be all the way above the graph, and we may or may not need that point. Now, since it's the entire parabola is symmetrical by the axis of symmetry, the reflection of 6, 3 will be on the other side, where we would have another point on this location, which would be at x -2, y +3. After we have at least 5 points, we will have enough data to graph our parabola. We can just connect the dots to finalize our parabola. We are going to now observe that the y-intercept is actually the c value. Our c value was -3, and our y-intercept is actually -3. Here's our word recap. We have learned about vertical stretch when the absolute value of the leading coefficient is greater than 1. Vertical compression when the absolute value of the leading coefficient is less than 1. A reflection when leading coefficient is negative, graph will flip, it will open down. Translation is when the function has a constant value, it will shift up, down, left or right. And axis of symmetry, the equation of the line, which is going to be x is equal to something which runs through the vertex. Vertex, the coordinate of the maximum or minimum of the quadratic function. If your quadratic function opens down, then you have a maximum point. If your quadratic function opens up, then you will have a minimum point. Now let me tell you a little joke as well. What do baby parabolas drink? The quadratic formula.